Okay, both of them are positive. Right, so from here, you can see that this is your XY plane. And I'm going to write this that this is our in plane, right? It has the bigger surface area. The other one, so this is your YZ plane. And over here, this is your XZ plane. Okay. So for this condition number one, stress Z is equal to 0. And we realize that the shear, okay, there's no shear. Okay, there's no shear for this example. So we're going to draw our 3D Mohr circle now. As I said, 3D Mohr circle does not mean you draw a sphere. You still draw circles. But now you draw 3 circles. Okay. So this is your stress, normal stress. And then still the same. Okay, so this is your shear stress. Okay, so shear stress, still the same thing like 2D, element rotate clockwise, element rotate anti-clockwise. So we know that stress X is greater than stress Y. Okay, so this line over here, your normal stress, and they're all positive. So this is our stress X line. Okay, so this is our stress X line. And then we have our stress Y line. Okay. And then our stress Z line. Okay. Because there's zero stress on stress Z, right? So we knowing there's no shearing stress around, we know that this is our point Z. Over here, this is our point Y. And over here, this is our point X. Okay, that's our point X. So we can draw one circle between X and Y point. Okay. So this is one of the circle. And this circle over here, it touches X and Y, point X and point Y. So this is your XY plane. And your XY plane is your in plane. Right? Because it has the largest surface area. And then you can also determine, okay, you can also determine that this over here, this is the limitation of the software. So if I draw a horizontal line across, right? This will be your shear XY or shear max for XY plane. Okay. And this one is your in plane. So like what we have done before, we always look at we just do XY, yes or no, right? We just do XY. And I want you to watch this, okay? At point Z, our stress is equal to 0. I highlight again, at point Z, our stress is equal to 0, okay? So in 2D Mohr circle, we only draw this, okay? Then in 3D, because in real life, everything is in 3D space, right? So before I go on, so if you just analyze the element in 2D, you're just going to select the material based on tau max xy, okay? And I want you to see what is the effect. So tau max xy is a smaller circle. Then the next circle I'm going to draw is YZ, okay? So YZ, so we're going to draw on YZ. Okay, so this is the other circle. And this circle over here belongs to the YZ plane. Okay, so this one is our out of plane, right? And what you realize is now the diameter goes bigger now. Okay. And then where do you have that? Over here now, which I'm drawing now. This is your shear max in your YZ plane. Okay. And it's out of plane. And what you can see now is your out of plane stress is bigger than your what? In plane shearing stress. If you base on your selection of your material based on tau max in the XY plane, your structure will fail if you don't put a safety factor. Yes or no? Right? And then the final circle that we're going to draw, as you can see down here, the final circle is going to be touching both the Y and the Z. Now this last circle, it now belongs to the what? Now this belongs, because it touches the X and Z, this belongs to the XZ plane, and it is the out of plane. Okay. And now this is the bigger circle, and when we design our structure, it has to be based on the biggest circle, not on your in plane. You see the problem now, right? If you just consider an in plane, your structure will fail, right? Because the tau max is the minimum. Why I keep on elaborating tau max? Because in a ductile material, right, the material will fail in shear for ductile material. That's why later on we are going to look at the shearing stress criteria. Okay, so from here, what you can see now, okay, I'm going to draw arrows again. Now this is what we call the true design work. This is true design work. Okay, what we have learned before is fundamentals. This is incorporating normal stress, shear stress, and the normal stress we calculate by bending moment. Shear stress is due to shearing stress, and it's also due to torsion. Now we combine everything down here. The purpose is to determine the principal stress. Okay, then we can select true engineering material. So what we calculate down here, this is our tau max. Tau max in the XZ plane, and this is the true tau max. The tau max that we have to be using for selecting material. Okay, so now this is equal to, so we realize that our tau max is out of plane. Okay, so that's where I'm trying to elaborate to you. In 2D Mohr circle, we only know what? In plane, in plane, in plane. Yeah, I'm trying to teach you all the fundamentals of Mohr circle. I use 2D. Now you see 3D. In terms of application, you realize that the in plane does not have the maximum shear stress now. It is the out of plane. Okay, so from here we can see that the tau max, okay, tau max is equal to tau max xz is equal to tau max zx, right? And this is equal to stress x, right, divided by 2, right? So you just take stress x divided by 2, right? Is the value of your tau max. Okay, and an interesting thing to realize that the maximum normal stress is equal to stress x. Your minimum normal stress is equal to stress z, and is equal to 0. Okay, so this is condition number 1. Okay, I repeat again, this is condition number 1. Okay, so now let's look at condition number 2 now. Okay, let's look at condition number 2. I'll bring this down. Okay. Sorry, you'll be coming back. My bad. Okay. So next, we are going to look at condition number 2. Okay, so condition number 2. Hey, sorry, it should be coming back. No, it's no more coming back. Yeah, it quitted on me. I have to go into it to get it to come back. So now we're going to do condition number 2. Okay, so condition number 2 is where we still get stress Z is equal to 0. Now stress X is negative and stress Y is equal to positive. Okay, so we are going to draw our element again, or our cube. Okay. So now stress X is in compression. Stress Y is in tension. And this is our stress Z is equal to 0. And as normal, we call this our point X, right? This will be our point Y. And over here, this is our point Z. I wonder, did we do the same from the diagram? The diagram above, there's something wrong with our diagram before already. So the diagram before, okay, I'm putting point X, point Y, and point Z. You can see it later on, okay? So now, we're going to start constructing a Mohr circle again, okay? 3D Mohr circle again. So this is our normal stress, okay, normal stress line. Then we have our shearing stress. Okay, shearing stress, element rotating clockwise, counterclockwise, 0. And this is also our stress Z line. Okay, now stress X now is in compression. All right. So that is our stress X line. Okay, so this is our stress X line. Then we have our stress Y line. So this is our stress Y line, right? And all of them have 0 shearing stress. So this is where your point X is, your point Z, and then this is your point Y. Okay. So for this case, right, we are going to draw our XY plane first. Okay, we're going to draw. So the XY plane, you realize now is going to be the biggest circle now. Okay. So right. So this is your circle for your XY plane. All right, and this is your what? Your in plane. And if you were to look at your shear, right, you can see it's evident that it has the largest shear. So if your stress condition is this way and you happen to just analyze 2D, you're lucky. Okay, it happened to work. So this is your shear max in the XY. Okay, which is also equal to your shear max, right? You know it's the bigger circle, and this is your in plane. Okay. Then we're going to draw the circle for YZ. Okay, so we're going to draw YZ circle. All right, so this is for your YZ.